Hello grade 5 and how are you doing? Today we will solve together the last chapter test, chapter 11 review test, and this is Miss Susan. Okay, so let's read together the first question here. It's all multiple choice. So Fran drew a triangle with no congruent sides and one right angle. Term accurately describes which term describes the triangle. Mark all that apply. So it has more than terms to describe the triangle. So first he said it's not congruent sides for the triangle, and he said it has one right angle, and we said we can describe triangles according to its sides and according to its angle. So the first description that works here, it's the name of the angle. It is a right angle, so we will highlight the first choice here, D. What is the second choice? The second choice, is it acute? No, it hasn't acute angle. Isosceles means two of its sides are equal, so it has no equal sides. Is it scalene? Scalene means every side has different lengths. So of course it has all its sides have different lengths, because he said there is no congruent side, so no sides are equal. So this is the second option here. Choose right, and we would choose scalene. So let's read number 2. Joe stores his baseball cards in a box like the one shown. So this is the box. It says a prism, right? It's a rectangular prism. Use the numbers and symbols on the tiles to write a formula, and we said the formula is a standardized rule. Okay, so he wants me to write a rule that represents the volume of the box. So he wants me to write the formula of the box. Symbols may be used more than once or not at all. So first he wants me to write the formula of the volume. So V, start with V equal, so the first thing that I will use, it's V. V equals what? The 3, multiplying the 3 dimensions together, right? What is the length here? It's 8. What is the width? It's 10. What is the height? It's 3. So we shall multiply the 3 numbers together, right? So complete the formula. V is equal 8 times 10 times 3. So what is the volume of the box? Now he wants me to find the volume of the box in cubic inches, because the unit here is in inches, right? So let's multiply and see. First thing is to multiply the digits first. 8 times 3 is equal 24, right? So 8 times 3 is equal 24. Then multiply 24 times 10. Put the 0 and multiply 1 times 24, so it would be 240. So the answer will be 240 cubic inches. Number 3, Mr. Mergado sees this sign while he is driving. For 3A to 3B, choose the values and terms that correctly describe the shape Mr. Melgado saw. So this is the sign. Okay, so in this figure has how many sides? It has 3 sides. And it has how many vertices? It should be here vertices. Of course, the number of vertices is the number of sides. The number of angles, if it's angles, so it is the same number here. So whatever it is what he's asking about here. It should be 3, same number. So let's add here like angles or vertices, whatever he's asking for. Okay, all the sides are congruent, right? So can you see that both 3 sides are equal? So the figure is not a polygon. Of course it's a polygon. A regular polygon named on any shape that has equal sides and equal angles. Not a regular polygon. No, of course. So the right answer here is, so it is a regular polygon. Okay, grade 5. Let's move to the next question. Number 4. What is the volume of the composite figure? And we said the volume, remember the formula or the volume, V is equal L times W times H. LWH. L for length, W for width, H for height. So we have to multiply the 3 dimensions together to get the volume. However, we have here 3 volumes, right? Okay, count with me. What is the width of each shape here? Each shape had the same width. The width is 3. So this is 3, this is 3, and this is 3. Okay, all the 3 shapes had the same height. 1, the height here is 1, the height here is 1, the height here is 1. But it has different length. The length here is 6. The length here is 6 minus 2 will be 4. The length here is 4 minus 2 will be 2. Okay, so let's find V1, V2, and finally V3. Then add them all together. Length is 6. The width is 3. The height is 1. The width here is 3 and the height is 1. So this is equal, 3 times 6 is equal 18. Let's find V2. V2. Okay. The length here is smaller by 2, right? So 6 minus 2 will be 4. So the length here will be 4. So it will be 4 times the width. I said the width is the same. It is 3. And the height is the same. The height is 1. Okay, so 4 times 3 will be 12. Everything is in cubic feet. And this also is in cubic feet. We should have the same dimension. Cubic feet. Okay, let's find the volume 3, the smallest one. Volume 3 is equal. Okay, we minus 2 from 4 to get this length. So 4 minus 2 will be 2. The length here will be 2 times the width. We said the same. It is 3 for all. They all have the same thickness. So it is 3. And the height is the same for all. It's 1. So 2 times 3 will be 6. And the unit is in cubic feet. Now let's add the 3 numbers together to find the overall volume. So the overall volume will be 6 plus 12 plus 18. So 18 plus 12 will give me 30. 30 plus 6 will be 36. So the final answer is 36 cubic feet. Let's go to question number 5. Match the figure with the number of unit cubes that would be needed to build each figure. Not every number of unit cube will be used, so not all the choices here will be used. We have only 3 figures, so in this case we will choose 3 right answers. Okay, so count here the cubes: 1 2 3 4 5, then 6 7 8, then 9. So it is 9 unit cubes here, so let's match it. The second one, we have 1 2 3 4 5 6, so each layer is 6. So we have here a complete layer and a complete layer. So this means I have 6 up and 6 down. So this will be 12. Match it with 12. Finally, this one. Okay, we have one complete layer down, which has 6. And we have incomplete layer up. Okay, so 6 down plus how many up? 1 2 3 4. We have 4 up. So 6 plus 4. This will be 10 in all. So we match it already. Is it easy? Super easy. Let's go to question number 6. Chuck is making a poster about polyhedrons for his math class. He will draw figures and organize them in different sections of the poster. Chuck wants to draw three-dimensional figure whose lateral faces are rectangles. He says he can draw prisms and pyramids. Do you agree? Okay, so first, what is the polyhedrons? We said polyhedrons is a three-dimensional shape that consists of polygons, right? Not any curved shapes. Okay, so if you can see any curved shape, so it's not a polyhedron. Okay, it's a solid shape but not a polyhedron. So polyhedron divided into prisms and pyramids. So if I have to draw three-dimensional figure, those lateral faces, its lateral faces are rectangles, so its all faces are rectangles. Is this a pyramid? No, it is not a pyramid, because the pyramid, its lateral faces, its side faces are triangles. Its lateral faces are triangles. However, the prisms are their lateral faces can be all rectangles. So what is this shape? It is a rectangular prism. So it's a rectangular prism. So let's go to part 2. Chuck says that he can draw a cylinder on his polyhedron poster because it has a pair of bases that are congruent. Is Chuck correct? Explain your reasoning. Of course, a cylinder, it's not a polyhedron because its faces are not polygons. It is a curved shape, so its both faces are curved shapes. No, because it contains two curved shapes on its base.